Hi, I'm Jeff Shield. I'm the Department Chair of Mechanical and Materials Engineering. I've been the Department Chair since 2011. I came to the University of Nebraska in 2001. My research is in the area of material science, technically metallurgy. So I work with metals and alloys, designing and building new alloys almost from the atom up. A lot of my research has been in permanent magnets. Permanent magnets are used in the fancy way as energy conversion devices. So mechanical engineering is a pretty broad field that encompasses a lot. In our department, we have people like myself who do a lot of materials engineering, which is making and constructing things almost at the atomic level. And we have people who are making devices and things that are on the meters scale, so meters big. Primarily, it's understanding and both the materials and the devices to make usable things to help society. Engineers solve problems. We like to solve problems. So a lot of the problems are related to mechanical engineering and motion, how things move, how things are built. Things that like we call dynamics. So what happens when things are moving? How can we make things better? You're well grounded in physics and the sciences, so physics and chemistry and math, and then a lot of the mechanical engineering fields of study. The 3 or 4 major ones would be like thermal fluids, that's like heat transfer or fluid flow. So the undergraduate program includes opportunities to gain knowledge in that area. In the design area, so we have a number of classes that deal with how do I design something so it won't break, and that of course includes motion, how things move. We have a lot of hands-on laboratories in our programs, so that's important for you to apply the knowledge that you learn in the classroom. We have a lot of opportunities for our students to be involved in extracurricular activities, which is part of the learning process, and we support a lot of different clubs, and they compete nationally, designing and building things. Well, one grand challenge is healthcare. We want to deliver better healthcare, prolong the quality of life. Outside of healthcare, we have advanced manufacturing. So we want to be able to make things more efficiently and stronger and better, and manufacturing is all about making parts. You will never work by yourself, and so throughout your career you're going to be working in teams. So you need to understand the dynamics of working on a team. Understand that maybe the person next to you is not going to do things exactly the way you would do them. How do you lead and how do you follow? Communication is a big deal. I mean, you have to be able to communicate your ideas to your teammates. You need to communicate your ideas to your bosses. So you can go work in a number of industries, large or small. Just a few off the top of my head. Locally here in Lincoln, there's a number of manufacturing companies that hire a lot of our graduates. One company builds pressure vessels out of fiber composite materials. There's another company that builds, railroad cars and off-road vehicles that require engineering. There's companies that do pharmaceuticals that have mechanical engineers working on the processing side, packaging. In Omaha, there's a number of center pivot irrigation companies, the 3 of the top 5 in the world or something like that, designing and building trucks and cars. We have some graduates in Detroit that work for Dodge and GM and Chrysler and all the big 3, and one of our graduates was in charge of the new Cadillac. More recently, we have a graduate that actually designs sunglasses for Oakley. For a time was the only engineer that worked for Oakley, so he had to be the resident expert in injection molding. That's how they make their frames. You think about, oh, I'll go work here and here and here. You don't think about working for Oakley and designing sunglasses. But yeah, an engineer helps out in even the most unlikely places.